In this video, we will calculate probabilities for a discrete random variable. An engineering firm takes on several projects a year. The following probability mass function shows the likelihood that X number of projects are completed on time. So this is our values. These are the number of projects that can be completed on time, and this is then the probability mass function. If we want to find f of x, this is our CDF, or cumulative distribution function. We can just add on a layer to this table and call this f of x. And basically, to find these things is we just take the cumulative probabilities. So the first one is pretty easy. It's 0.02. Now we add these two together to get 0.07 for the cumulative function of 1. And then we add all three together to get the next value of 0.17 and continue to do that. So this is 0.33, this is 0.55, this is 0.82, and lastly, adding 0.82 to 0.18, we will get 1, which we should always get as our last value for our cumulative distribution function. Okay, so now we can use that to find probabilities, or we can use the probability mass function. So this question asks, what is the probability no projects are completed on time? So that's the probability of x being equal to 0, and that is simply just equal to 0.02. So that one is just found straight from the probability mass function. We also should find the probability that exactly 4 projects are completed on time. So that is the probability that x is equal to 4 is equal to, then right here from the probability mass function, that's 0.22. Now we want to find the probability that x is between 2 and 4, where we include 2 and 4 in our probability. So we can find this a couple of different ways. This could be equal to the probability of x equal to 2 plus the probability of x equal to 3 plus the probability of x equal to 4, which is simply just equal to the values found in the PMF, which is 0.10 plus 0.16 plus 0.22, which altogether are equal to 0.48. Now this is one way that we can find the probability. Another way that we can find the probability is using the CDF. So this probability is exactly equal to the probability of x being less than or equal to 4 minus the probability that x is less than or equal to 1. And so that is the same as it being equal to 2, 3, or 4. And now we can use the CDF. So the probability that x is less than or equal to 4 is simply just equal to 0.55. minus the probability that x is less than or equal to 1 is 0.07, and this is equal to 0.48. So if we know how to manipulate the probabilities, then we can use the CDF and have a slightly quicker calculation for D. Now for E, we should definitely use the CDF. So for E, it asks, what is the probability less than 4 projects are completed on time? So notice this wording. It says less than 4. So that doesn't actually include 4. It means 0, 1, 2, or 3. So that is the probability that x is less than or equal to 3. And we can use our CDF to find that, which is just equal to 0.33. Again, we could add up the individual probabilities as 0, 1, 2, and 3, but it would take longer than just looking at the CDF. All right, so for F, what is the probability at least one project is completed on time? So let's write that out in notation. The probability that at least one project means the probability that x is equal to or greater than 1. All right, notice the difference in our equality here and how we're asking for a greater than. This is equivalent to 1 minus the probability that x is less than 1, which is equal to, so this doesn't include 1, equal to 1 minus the probability that x is less than or equal to 0. So we can simply just, again, use our CDF or even our PMF here because it's the exact same value. So 1 minus the probability that x is less than or equal to 0 is simply just equal to 0.02, which is equal to 0.98. Now I calculated f this way because we could calculate it like this using the complement, or we could have found it by simply saying, okay, the probability of x being greater than or equal to 1 is also equal to the probability that x is equal to 1 plus the probability that x is equal to 2 plus dot 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 plus the probability that x is equal to 6. And so we could have done it this way, but it would have just taken more time to add up those values, so we can also use the complement and really minimize our calculations. All right, hopefully this video helped you understand how you can take probabilities with a discrete random variable.